This is the Amp Hour Podcast, recorded August 18th, 2014, episode 212, with guest Trey German, Launchpad, Laden, Lodesman. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Trey German from Texas Instruments.
Welcome, Trey. We are Dave-less this week due to some scheduling issues, but my fault, actually. And we're glad to have you, though.
Absolutely. Glad to be here.
A Texan. I am a former Texan now.
I don't think I knew that. Where were you at when you were in Texas?
I was in Austin at Samsung for a little while, for about 2 years.
Okay.
But,
yeah, I've driven by there. That's a huge plant.
Yeah, they make A6 chips, I think now, Apple A6. So.
Oh wow, yeah.
Yeah, so I know Texas Instruments has lots and lots of locations. They have, I know in Richardson they have some fabs up there. Are you near the main Richardson site, or where are you?
No, I'm actually down in Houston, more specifically Sugarland.
Oh, cool.
So we actually we just built a new building and moved into it in early June. So we're all really, really excited about that. It's a big upgrade.
Okay. But like just better offices, that kind of thing. Like no fab, right?
Yeah. So there actually used to be a fab down here in Houston, and they shut that down about a year ago. And so we were in a building actually next to it where they actually used to make printers back when TI still made consumer electronics. So we were in an office space there. They built us a new building. So now we're down in Sugarland, really enjoying it.
That's cool. Yeah. And that Houston has some decent barbecue. Not as good as, around Austin, but I hear Houston's pretty good.
Oh, absolutely.
That's what I miss. I miss it a lot.
Yeah. No, you got to love a good slow smoked brisket.
Oh, yeah.
There's nothing quite like it.
Yeah.
There's plenty of great food. That's one thing I really missed when I went up to school. Was all the great food down here up north. I was in a small town in Indiana. The food was just so bland.
Yeah.
So I always craved, fajitas and things like that when I came back down here to Houston.
Yeah. Oh, so I didn't know you were a native. Where the hell's the accent, man? Y'all.
I actually I grew up down on the southeast side of town in a little town called Friendswood. So I grew up there. My family's actually from Indiana, where I went to school. So that was kind of nice.
Oh, yeah.
Back down here and loving it. Houston's a great city to live in.
Yeah. So let's talk about school a little bit, because I think you're our first guest who went to Rose-Hulman, which...
Really?
I think so.
That's great.
It's surprising, right? So
yeah.
Here's my experience with Rose-Hulman. I went to Case, which is here in Cleveland, right? And
right.
I went to go interview at GE Aviation, which is in Cincinnati. And I've never met so many people from, basically they tried to pull every single person out of their senior class of Rose-Hulman and get them to work at GE Aviation. I never heard of it before I showed up that interview. And it was very jarring to me, because I'm like, who the hell are all these smart kids?
Yeah, that's one thing we're known for. It's a really great engineering school that, most people have never really heard of.
Yeah.
And so, my dad actually went there, and so that's how I kind of learned about it. And I did a summer camp program there between my junior and senior year of high school.
Oh, cool.
Called Operation Catapult. And so we got to go build real electronic things, or really whatever you were interested in. Excuse me, it's a school that has many different disciplines. So when I was there, we made a little holonomic robot, which was kind of cool. So for those of you that aren't familiar, a holonomic robot is it's a weird word, but the concept is actually pretty cool. You've probably seen these wheels for robots that are out there. They're kind of plastic. They look like a normal wheel. Instead of treads around the outside, they've got these little rollers, so they can roll kind of parallel to the axis of the wheel, if you will. So orthogonal to how the wheel would normally roll. But they can also roll in the the normal axis. So what you do is you put one of these on each corner of a triangular kind of robotic frame, and you can rotate smoothly in 360 degrees, but you can also move kind of laterally as well. So you can actually combine these to spin the platform as you travel like a line. So that was pretty cool, and a really good introduction to the school.
Very cool. Then you just kind of jump right in and you're like, I got to go here, that kind of thing.
Yeah, the thing that really sold me was kind of the campus community and the people that were there. That's what really made it special for me. It was kind of like a big family. When I was there for this summer camp and then subsequently in school, people didn't really lock their doors. Everybody had a great deal of respect for each other. And that's what really made it special. And we had some fun too.
Of course. Well, you got to let off some steam
college.
as an engineer.
Oh,
yeah.
Oh, absolutely. Absolutely.
So, and it's not that big though either. I remember it being like 400 or 500 like undergrads or something. Maybe I'm wrong with that.
No, the classes were probably about 400 or 500. So,
okay.
My graduating class, I think, was somewhere in there. Total student population, I think, is somewhere around 2,000, maybe a little higher now. The class sizes have been increasing a little bit, but yeah, it's a really small school, a real tight knit community. It's kind of a closed campus outside of town. Lots of beautiful nature. There's lakes. It's a really pretty place. Yeah.
Yeah. Was it because was it the list also that like there aren't PhDs there, like they don't grant PhDs? Is that the other thing? Yeah. So the highest degree that the school offers is a master's. So they really focus on undergraduate education. In some of my higher level classes, I had classes, with less than 10 students in it. You personally knew, all your professors. Yeah. Actually one time, this is a pretty funny story. His name is Dr. Hernader, and he was kind of a power electronics kind of expert, did a lot of stuff with cars, taught our basic kind of like transistors class, things like that. So I was in one of his classes, and he was always really hard with the grading, and it was around Halloween time. So to get some extra credit points on the test, I think he offered us like 20 points or something of extra credit if we dressed up as, what was it? I think it was like John Travolta in the movie, what was it? I don't know. Saturday
it was
Night Fever
one
or Grease or something like that?
No, we had to cross-dress. So it was a movie where John Travolta was dressed up as like this overweight woman with like big hair and stuff like that. So most of my classmates and me, we dressed up like this, albeit kind of half-assed, and then went to his house, 10, 20 miles away, showed up at his doorstep to trick or treat and get our bonus points for that test. So that was an interesting night.
Never underestimate the desire of nerds to help
get good grades.
Their yeah. That's awesome.
Absolutely.
Oh, that's great, man. That's great.
Yeah.
So then, what was post school? So I heard you telling someone about the 2009 kind of time frame was kind of rough or something like that.
Right. So I graduated kind of at the in the middle, towards the end of that kind of economic downturn that we had here in the U.S.
Yeah.
And so
I bought a house then. It was fun.
Well, yeah, I mean, if you had the money to do it, it was a good investment.
No. I bought it right beforehand.
I see.
Yeah.
That
how to
sucks.
swim.
But but yeah, after school, I had been working at part of the school called Rose-Hulman Ventures. So they do like kind of consulting engineering for industry. Industry will bring in problems that they have or projects that they need done. And then Rose-Hulman Ventures hires students to do those. So I was working there for a really small software company at the time called Sima Software. And I was an intern. And so after the summer expired and I could no longer work as part of the Rose-Hulman Ventures program, Sima Software decided to hire me on full time. And so what they did was CAN software. So CAN is Controller Area Network. It's a differential serial bus that's used in automotive applications. And so I got to work a lot with CAN software. So I wrote things like bootloaders. I worked a lot with TI parts there, and I also designed some of my first real hardware products that were sold. So that was pretty cool. So
what kind of stuff?
So I made some like CAN adapters. So think like serial to CAN, Bluetooth to CAN, Wi-Fi to CAN, all those kind of just different interfaces to different automotive networks. So in addition to CAN, they did another network called J1708, which typically you implement it with a standard UART. And if I remember correctly, I think it was a 485 transceiver or something like that. Just products to interface to really big rigs like 18-wheelers, things like that.
Yeah,
not
industrial
so much
level type.
Yeah, not so much consumer stuff.
Oh, that's the fun stuff anyways, because then it's got to be ruggedized, it's got to be like super reliable. You get to actually really test stuff well. They allow time for testing that much stuff well.
Absolutely. Yeah. So
that's cool.
That was I really cut my teeth on software there and learned a lot about kind of all the things they didn't teach me in school,
Yeah.
Is that first kind of little bit of real world experience.
So you said there was a bootloader, it got loaded over CAN. So basically you're like reprogramming something over CAN? Is that the idea?
Yeah, exactly. So if you think about it right, you've got all these different microcontrollers throughout a vehicle. And let's say somebody discovers a bug in the firmware of one of them. You can't really pull those things out of the car and open them up, plug into the JTAG header, and reprogram them. So this is something that's commonly done in really a lot of products, right? You'll have a little bootloader, which is a small program that resides in Flash. And when the device boots up, it runs this bootloader first. And normally what the bootloader does is it checks the application for validity. And then if it's valid, it'll actually transfer execution and start executing the real application. Well, if you need to update that application, you got to have a way to do that. And so that's what this bootloader code does. Typically, there's a way for the application to enter back into the bootloader, and then the new application software is loaded over some type of communication network. In this case, it was CAN, but this can be done with USB, just a simple UART. Really, any way that you can get information into a chip, you can use to load applications into it.
So you'll have to excuse my presence temporally to DEF CON. I was just at DEF CON, so I'm thinking about security still.
Sure.
Does that mean if someone kind of tapped into the CAN bus network, they could say you put a Bluetooth device on a CAN network, would it be possible for someone to try and reprogram parts of a car kind of thing?
Absolutely. With the right knowledge. But, a lot of this stuff is proprietary protocols. So while the information, you can see the ones and zeros, you don't know what the ones and zeros mean. And sure, that can be reverse engineered through a lot of time and effort or, social engineering, trying to get design specs and things like that. Mm-hmm. But it's not something that's easily done is what I would say.
Okay.
And, the data, if, you had a tool, had an update program on it, but you couldn't get to it there, you could attack the CAN bus itself as it was transferring that update for the firmware. But there's also, ways that you can encrypt that communication. Even though the CAN bus data itself isn't encrypted, you can encrypt the kind of data that it's carrying.
Right. Yeah, it's just hanging out there, but
yeah, exactly.
The packets it's sending are already encrypted and need to be decoded on the other end, right?
Exactly. Mm-hmm.
Huh. That's pretty cool. Yeah, I was wondering about that stuff too, because I think we've talked to Tom about CAN stuff when he was on the show. That stuff's never open to the user, right? For good reason, right? Because there'd be so few users that would actually want to in the first place, and then it could be a hazard if they do. But I always wonder about that, why, if anyone would ever open that stuff up to users to actually allow mods and stuff like that.
So, I think, I'm a little bit of a car guy too. And so, there are tools out there So the OBD stuff is standardized. There's tools. I think one is out there is called like ROM Raider or something like that. But they're tools that connect to your CAN bus in your car with the OBD2 connector. And then you can actually kind of reprogram the main engine control module. So remap the fuel tables, change, boost pressures if it's a turbocharged car, mess with spark timings, all that kind of good stuff. So tools to do that. You're typically only going to see that for, cars that people like to mess with and kind of hot rod and stuff like that.
So you mean a Honda Civic, a 200004 Honda Civic? Is that what you're saying? Like I have?
Yeah. So, you could get your rice front. Yeah, you can get your rice burner and, hack the ECU.
I don't think my thing's going very fast ever.
No.
And I'm okay with that.
Yeah. Anymore I find myself, chilling out when I'm driving. I'm like, I just got to get to work. There's no rush. There's no reason to risk a speeding ticket or anything like that.
The only upgrade I need is self-driving. Once I get that, I'm done.
That's gonna be nice. I can't wait for that.
Yeah, especially in Houston with all the freaking traffic there, right?
Oh man, it's bad. Thankfully, I live. We call it inside the loop here. So we've got 2 loops, and inside the inner 610 loop, we like to say that's where all the cool kids hang out. So I do the reverse commute.
Oh, okay, that's good. Yeah.
Yeah. So it's probably about 30 minutes out and back to Sugar Land every day each way. So not too bad. I think a lot of people have about a 45-minute to an hour commute. So my 30 minutes out to Sugar Land isn't bad.
Man.
Yeah, I can't complain.
Well, my commute is now 30 seconds.
So are you still up in, Cleveland or?
Yeah.
Okay, so you're going to work for Supply Frame from there?
Yeah, no, I do. Yeah, I work for me and Supply Frame, so.
Okay,
yeah, right. So enough about me, but what about you? What about so from there you found your way to the monolith that is TI, one of our favorite companies at the Amp Hour. How did that happen? Like how'd you get started there?
So we actually had a FAE come to visit us at Sima Software. So we were looking at some TI parts and talking to him, and I got a chance to interview with him. And so I did an interview. They did a follow-up.
Wait a second. Did he come to your office to interview, or did he just came and he told you about a position?
So there's some specifics there that I don't want to discuss because it has to do with Sima Software.
Gotcha.
But I interviewed with TI and had a follow-up technical interview that went well. I think I answered every single one of their questions, and so they flew me down to Houston to interview with the C2000 team, and I didn't know it at the time, but I was going to be like a perfect fit for this job.
Yeah.
Go ahead. What were you going to say?
Oh, Sima. Well, I didn't piece that together. So Sima was back up in Indiana still, right?
Yeah, Indiana.
Oh,
yeah.
okay.
So it was in the same town that I went to college in.
Gotcha. Oh, cool. Okay. So then, that works out. Man, that's like that sounds like serendipitous, huh?
It really was. Things I think were just meant to work out that way, and so I'm pretty glad they did.
Yeah. So you said the C2000 group, right?
Yes. I interviewed for a position in C2000. And like I said, I didn't know it at the time, but I was a perfect fit for the job. So some of the work I had done at Sima Software was with one of the then Luminary Micro LM3S microcontrollers. So they're
that's right.
Just a general purpose kind of ARM Cortex-M device. Well, while I was working with them at Sima Software, TI bought that company.
That's right. That was about 3 years ago, right? Or no, more than that, obviously.
Yeah, I think it was a little before that. I want to say it was, it probably would have been 2009-ish, 2009, I think. Yeah, somewhere in there. Anyway,
okay,
so I was playing with those, and I had an opportunity to get familiar with USB, and I had never really done USB or anything at all like that, but I was like, oh, this will be cool. It's the peripheral that's really, if there's one peripheral that's prolific kind of throughout our lives, I would argue that it's USB, or it was USB at one point. So
yeah, it still is there for sure,
Yeah.
right? Just not
sure,
the only
it's
one.
still there. Exactly. Yeah, so I got a chance to get familiar with that. So back to the story at hand. So I interview, and they're asking me all these questions, and they're like, "Do you think you could, port the USB stack for that device to a new architecture?" And I didn't have any experience porting that much software of that magnitude, a whole protocol stack. But I was darn sure going to give it a try.
Yes, sir.
So,
You're right away, sir.
Yeah, I'll take the job, right?
Yeah,
So
yeah.
I accepted a position in the C2000 group as a validation engineer.
Okay.
And so what I was doing there was kind of beating up silicon, both before it physically existed and after it physically existed. So
Does that mean you're the guy that writes errata? Is that like you? Like,
yeah, so I did the job of finding those bugs, and if there was something that we couldn't fix, we would write an errata for it. So that was part of my job, and one of the peripherals that I was given was USB. And so what we had done is we had taken the USB peripheral, the IP for that from the Stellaris device there. And basically put it on one of our C2000 devices. So C2000, it's a proprietary architecture for those of you who aren't familiar. It's a 32-bit, kind of really optimized for real-time control applications. So we do, DSP, running control loops, IAR, FIR filters, all that kind of good stuff.
I have lots of questions about that. We'll get to that.
Okay.
Yeah.
So yeah, we do all that kind of good stuff, but it's a different architecture. And the thing that kind of makes it different is that the memory locations in it are all 16 bits wide. So normally you think of a byte as 8 bits. Well, actually on our architecture, a byte is 16 bits.
Oh man! So how many times did you
yeah.
curse the architect's name for that one? Like,
in porting, normal byte addressable software, it can be a little frustrating, but it's imminently doable.
is that like setting up different bit masks then, or like what ended up having to be the big changes there?
Okay, so I'll explain the big change. Basically, this data would come in from the USB peripheral into these FIFOs, and it would come in a byte at a time, a normal 8-bit byte. And so we would copy that out into memory, and so we would have these 8-bit bytes sitting in 16-bit locations. So first of all, we're not using half of the memory here. Secondly, the way the stack was written is that it had these structures. So, you've got a bunch of unsigned chars in a structure, or the chars were okay, but it was the shorts and the longs.
Yeah,
so
right.
16, the variables that were supposed to be 16 and 32 bits long. So if you think about this now, the compiler interprets the byte wide members of the structure as a single memory location. Excuse me. It also treats the 16-bit members as a single byte location, and the 32-bit members as a two address location, if you will. Sorry, that was terrible explaining.
So yeah, it's like 2 bytes, but not normal bytes, right?
Yeah. So
why didn't you change the name so they're not like bytes? It's like bits, no, not boats or something like that. Instead of
a lot of times I'll use words instead of bytes to kind of help clarify that.
Yeah.
But basically, these structures, when they were typecast over memory, none of the fields lined up, and so that was the main problem that I had to deal with.
There was
a few other. It required a lot of changes, but the changes were all very uniform. So I tried to solve it in a way that was somewhat extensible, if you will. So what I did is I basically defined some new types. And so for these types, I made them match up between what they were supposed to be, like the number of locations they covered, and how they were. So basically, the shorts became 2 shorts, or Yeah, the shorts became 2 shorts, and the longs became like 4 shorts. So basically, and then I wrote macros to kind of decode these things. So anywhere where I accessed one of these in the code originally, I had to add this like little helper function to read the data out or write it back. And that was a little tedious, but it worked.
So let me ask a really naive question then. Naive because I'm not really sure what's involved. Why not just write a USB stack from scratch then? Like, was it that much less work?
Well, yeah, I would say so.
Okay.
USB is a pretty hefty protocol stack, and supporting all the different examples that we had, all the different device and host classes that the stack supported.
Oh, yeah.
That would have been a big effort. Plus, it's reuse. We wanted to kind of stay in line with the other teams that were using this piece of IP, because if they found a bug, they could fix it and we could take their fix. And if we found a bug, we could fix it and they could take our fix. So, it actually does help to make the software higher quality.
Okay.
So there's valid technical reasons to kind of do it that way.
Yeah, no, that's a great explanation for sure. And I asked that as someone totally oblivious from the USB stack. Now, the one thing that I do know about stacks is whenever I hear stack, I think RTOS. Does that mean you had to build that on top of an RTOS?
No. So a protocol stack is kind of it can be independent of an RTOS.
Okay.
I would say that there are stacks out there for certain communications peripherals and things like that can play nicely with an RTOS, but we've got stacks that go either way. So the USB stack, for instance, it's not written for an RTOS, but with TI RTOS, so we've got a RTOS that we have written in-house within Texas Instruments. They've taken that and kind of integrated it into their package. So they plug all their interrupts into their hardware interrupt handler. Any periodic tasks that need to be done are done as part of the RTOS instead of using like a dedicated timer or something like that. So, RTOSs are cool. They're awesome. They're a very useful tool sometimes, but they're not necessarily required in any embedded application.
I thought they were for like Ethernet type stacks where maybe I'm wrong about that too.
Nope. So we have a couple devices that run a stack called LWIP. It stands for lightweight IP. There's also another one called micro IP, and neither of those require a RTOS.
Okay, cool. That's good to know. Yeah, because I'll stop saying that then.
Yeah, I can talk software all day.
That's good, man. That's real good. We don't get your kind around here very often.
No.
Well, I mean, here and there. I mean, obviously we've had like Jack and Alicia on the show, and they all are firmware-y folks, and mostly I'm scared of you, so
I gotcha. Well, I like doing hardware too. So that's I think hardware was my first love, and then software was kind of a means to an end. You build the hardware, but then a lot of times you need software to run on it to make it do what you want.
Yeah.
And so I kind of learned software so that I could make really cool hardware.
That's good. So do you get to so your title was applications engineer then, or
that's what I tell people. So I started out as kind of a validation engineer. Then I actually moved to our software team.
Oh, cool.
So I was in the C2000 software team, and did all that stuff, did Launchpad, and I actually just accepted a new role within TI.
Ooh, do tell. The world exclusive here?
Actually, yeah. So I haven't announced this publicly on any social media channels or anything like that, but I'm very excited to announce that I just accepted a role as Launchpad Applications Manager.
That's awesome. So now every time someone wants a Launchpad, we'll give you Trey's Twitter handle at the end of the show. It's his name backwards, basically.
You figured that out.
I figured it out way too late. Yeah, I was like, what the hell is that? His first name backwards, then his last name backwards. But yeah, That
I'm trippy like that.
you can bug him on Twitter now. Like, hey man,
absolutely, yeah,
yeah, that's great. Well, congratulations. That's really good. And Launchpad is doing great. I mean, like, I see those a lot of places. I mean, it's in the mix with all the other dev boards and stuff like that. So very cool.
Yeah, no, yeah. So I designed the original C2000 Launchpad. So I was very excited to kind of do that, and honored really to be part of such a great platform.
Yeah.
So yeah, we've got a lot of really cool stuff actually planned for Launchpad and Energia. So if you're not aware, Energia,
which is a great idea with a terrible name. I
you don't like it?
I call him how I see him, man. That's a terrible name.
Well, you know the story behind it, right?
No, I don't. Maybe that'll change my mind. I don't know.
Okay. So,
maybe we should tell people what it is first, right?
Okay. Absolutely. So, Energia, for those of you who aren't aware, it's a wiring software for Launchpad. So, wiring is the language that Arduino uses. I believe processing is the IDE that they run it in. And so basically what we've done is we've forked their project on GitHub and created our own open source project called Energia. And so what you can do is basically take an Arduino sketch or, write your own sketch in wiring. And with Energia, you can compile it and download it to most of the Launchpads.
Yeah, because right now, if you go into the Arduino IDE, the hardware that you can select is mostly Arduino stuff. I haven't looked in a while, but
right.
They have like pull downs for all the different
exactly
codes and
so
stuff.
We've basically added support for our Launchpad. So wiring is not something that's exclusive to Arduino. It's actually used in a lot of places, and so it's kind of the de facto standard for the maker community, and that's something we want to support. And so we've come out with this.
Well, that's great. Yeah, that's really great. And so the other thing I was going to mention too is the Launchpad started with the MSP 430, right? That's the one that most people know about it. So why did you design the new one in there?
We basically saw the success and how popular and how innovative the MSP 430 Launchpad was. It brought things like a debugger to the table that dev boards like the Arduino had never had before.
Which is a shocker if you're expecting a debugger. By the way, that happened to me.
Right? Yeah. It's kind of blow and go with one of those. Keep your fingers crossed that it works. So we saw the success of that and how it was enabling customers to try out this platform because of how low cost and easy to use it was. And so we wanted to kind of do the same thing for C2000. So there's actually a whole big long story behind the C2000 Launchpad that I could tell sometime, but I don't think we have time on this show. But yeah, so we developed the C2000 Launchpad, and I took it all the way to production with a Chinese contract manufacturer, and that was an experience in and of itself. But a great one, a great learning experience there. And so we came out with the C2000 Launchpad, and that's where it sits today.
Is it pretty overkill for what it is? I mean, it seems like C2000 is pretty, or some of the variants are pretty powerful. Is it kind of overkill or?
So I don't think so.
Says the guy who writes software for it. Yeah. Okay.
Right. I like having, enough horsepower and, RAM and flash that I don't have to worry about it, especially for dev boards like this. You're going to spend an extra, $5 to get, 50 megahertz of performance or something like that more. Why would you not, spend the money to just not have to worry about stuff like that? So it's a 60 megahertz device. It's got, I think about 40 IOs. It's got JTAG isolation, which is nice. A lot of the stuff that we do in C2000, I don't think I really covered that. I said digital real-time control applications. What's that, Trey? Well, what it is
hey, I'll ask the questions here, mister.
What it is basically any apps where you have to sense the analog world, do some DSP, control algorithm kind of stuff, and then interact with the real world. So a good example of this is like a switching power supply, right? You're monitoring the output voltage, the load current, all that kind of good stuff. And then you're running a control loop to adjust the duty cycle of your PWM to kind of control those parameters. So traditionally, this has been done with analog control ICs, but now there's this kind of movement to bring this to the digital world. And that's
which I don't agree with.
Yeah, Chris is gonna fight me tooth and nail on this, right. But I would argue that it's actually a better development flow, and the reason for that is, if you calculate a filter value wrong, right? If you're doing this with an analog control IC, you've got a network of resistors and caps, maybe some op amps in there to buffer things. And so you've got to go back, completely recalculate all those components, unsolder them from the board, solder new ones on there. Maybe you have to order new components. That can be very time consuming. When you do this digitally in software, you recalculate the coefficients for your filter and you just change the code. You recompile it, you flash it, and that took you 5 minutes instead of an hour. So it can be a big time saver.
I don't know, man. You wanna have it out on this one? All right, I'm stretching here. I don't know if you can hear me. All right. So what about? So that means you have to have. Now, I would agree with that if you are already pushing code specifically to that device. I would say though the cost of maintaining another firmware image is not worth it compared to a low cost switching regulator. So like I'd rather have a set and go resistor capacitor, assuming it's a static application, right? Maybe that's not a good assumption. But if you're just doing maybe in again these are the simple cases, not where you do it, but like if you're just doing a normal switching regulator, 5 to 3.3 kind of thing, an amp or so, why wouldn't you just use a regulator?
Right. No, you're absolutely right. And in a simple application like that, I would not argue that there's a need for a more complex control solution like a C2000 device.
So where are they then? Where are those places where it really is needed?
If you think about like server power supplies, so think of like a big data center, right? They want those power supplies to be as efficient as possible, right? Because every fraction of a percent of efficiency translates into big money when you've got thousands of computers burning electricity. So an application like that, you can actually go in, if you're able to find a more efficient way to switch the power, you can go in and update the firmware of the device and see real financial gain from that. Okay,
that's kind of cool. Yeah, is that like PM bus as well? Is that something you guys do as well?
Yeah, that's something we're getting into. Yeah, absolutely.
Cool. Yeah, that's like the control, or that's the communication network, right? For doing that upgrading.
Absolutely. So that's based on I2C. So okay. But we're in a lot of other cool applications too. I can't tell you any specifics, although I wish I could. But things like electric cars, the big switching circuitry that drives the main traction motors, we're in some of those. So, really actually pretty cool applications. Elevators, motor controls and power supplies are basically our big one.
Right?
Sometimes I'm lazy and I like to hop in an elevator instead of taking the stairs.
No, that is cool though, because like control systems in general, they are mind-boggling sometimes, right?
Absolutely.
Like you said, calculating those coefficients, making sure you have a properly damped response, all that good stuff from your control system theory classes that everybody took out there, or will take, or fears taking, or has nightmares about still.
That was me. Fears taking. That was me.
Yeah. But that stuff is really important, and it does have these real world impacts, right? So,
absolutely.
So my experience is, and I talked about it on the show, and I stopped talking about it because I stopped working on it. But I have the high voltage, the kit using the Piccolo, which is one of the C2000 variants, and actually doing a AC induction motor, which is similar to a lot of those electric cars, like you mentioned. Like the Tesla uses a AC induction motor, I know. So it takes that huge battery stack and then monitors that, and then also can basically inverts it using the big switches, right? So That's very, very cool stuff, and it makes things move and
Absolutely.
look awesome.
Yep.
Move things very quickly.
Mm-hmm.
So did you, when you were working on the software stuff, was it mostly on the peripheral side of things, or did you also get to dig into the DSP? Because that's a piece that I don't quite understand how that all plays together.
I've kind of stuck my toe in it, but the math involved there is it's pretty serious stuff. I've gone to a couple of sessions. We've got a guy in our group that puts on these control theory workshops, but I'll be honest with you, sometimes some of that stuff, it just kind of whizzes over my head. But we do this DSP. Basically, my focus has been more on the peripheral side of things, making sure that part of the chip works. But then we work with our systems team, and they develop libraries for everything from, DSP math, like I was saying, the different filters, FFTs, things like that, to things for digital power or motor control. So we supply like little assembly blocks that you can implement, all kinds of different transforms that are used for motor control. We've got solar libraries, libraries for power line communications. That's another application area that we play in.
So what's an idea of like the response time? So you mentioned like assembly, so that usually implies that it needs to be super, super quick. What's the response time that you need to get like in a control loop? Do you need to get like millisecond response or less, or do you know that kind of stuff?
It really depends on the application.
Okay.
Digital power applications are typically a lot higher frequency than something like motor control. So for motor control, I think they typically run their PWMs in, the kilohertz range, anywhere from like 10 to 30, somewhere in there. Digital power, you're looking at 100 kilohertz plus.
Okay.
And so...
Yeah, I guess that takes the size of your inductors down as well when you start doing higher frequency stuff, right?
Absolutely.
Yeah.
It really just depends on the application. But, a lot of applications, it does get kind of tight. And so that's why we're building, higher end devices. So we just came out with a device that has a whopping 800 MIPS of performance. It's a beast, let me tell you. It was fun working on it.
I have see, that's the thing. People say MIPS, and I'm just like, I don't know. I mean, I know it's mega instructions per second, but like, okay, like,
what does that mean? Right?
Yeah, what does that mean to me? Like, I've never gotten personally to the point where I'm like, oh, I'm out of juice on my processor. I'm like, where's the manual to my processor? You know what I mean?
Right. Yeah. So most of the time, as hobbyists or makers, people don't get to that point.
Yeah.
But when you talk about people that are building, real high-end, high-performance applications, they get to the point where they use up every last little resource within that processor. One time, actually, when I was working for Sima Software, I bit banged CAN in assembly, and I was using up. This was on an MSP 430. I wrote this thing.
That's your own damn fault, there, Trey.
No, this is my job. This was on a 16 megahertz MSP 430, and I was counting, every instruction, like how many cycles they took.
Wow.
I had very carefully partitioned my RAM because I think it only had like 256 bytes of RAM or something ridiculous like that. So I'm having to really just hand optimize the crap out of that thing. And
that's awesome.
People have to do that in industry too. And so that's why we want to supply things that are as efficient as possible. And that's really where we excel.
Yeah, that's really cool. Yeah, and I wanted to call out as well on so Trey mentioned the math on motor control stuff, and it's just like it's entering a whole different world. So there's Clark transforms and Park transforms and all these different macros and what is it, Kermod macro? I'm just looking at a block diagram right now. Honestly, I have no idea still what it is. So basically these feedback mechanisms though that then they shape the data and basically do stuff with it.
Yeah. Would you like to know what they do?
Yeah, I definitely.
Well, I can tell you. I can tell you a little bit about it.
Okay, let's hit it, man.
Yeah, basically, one of the big kind of technologies that we're really excited about. The marketing name for it is InstaSpin.
There's some guys in Cleveland do that stuff, I think. They do some
line stream stuff, absolutely. So what we do is called field-oriented control. And basically, this is a way to commute a three-phase motor, and we do it sensorlessly. So what does that mean? Well, typically, you would have like a Hall effect sensor, a magnetic sensor attached to the motor, so you could tell where the flux from I always get the stator and the rotor confused, so you'll have to forgive me.
Me too.
you can tell where one of those is, basically.
Okay.
And that allows you to place the flux vector from the coils at exactly 90 degrees to very, very efficiently spin that motor. And so the special piece that we have is making that sensorless. So we don't have a Hall sensor. What we do is we measure the currents and voltages on each of the phases, and using a special piece of software, we're actually able to generate that flux vector from that information and then very efficiently control these motors. So we can control these motors, I want to say, at greater than 90% efficiency. I don't know the exact numbers on this, but really, really efficiently.
Right, which really matters because I'm looking at my kit right now. So I have the kit, the high voltage kit, and it can do up to 1.5 kilowatts. So even at 90% efficiency, you're burning 150 watts, right? I mean, like that's pretty beefy.
That's a lot of heat.
Yeah, that's a lot of heat. It's got some crazy ass heat sinks on this thing. So
So anything you can do in these applications to really wring more efficiency out of your power stage is very important, and that's what we're all about.
Right. Yeah, and the other thing I think to mention too is that like the thing that usually is crazy is that you have dynamic loads, right? So that's really where the crazy piece comes in. That's the thing that blew my mind, is like thinking about it. Okay, even just getting it up there and like measuring it. Okay, I know the current, I know the voltage of these coils, and I can feed that stuff back in. And then now, something happens and your wheel falls off, or something grinds up, and you have to respond to that. That's an extreme example, but there's always these feedback type things where the external stuff messes you up like crazy.
Yeah, no, changing loads, dynamic stuff like that, that definitely can trip you up, but InstaSpin is able to handle that.
So I should mention as well that when the Line Stream guys came out to one of our meetups, and I don't think I've posted the video yet, but they brought one of their demos. It had this single axis stage where it was like for a conveyor belt, right? And they could control stuff really, really well. They put a beer glass on it, and then it was like zipping, and basically they can control the acceleration, deceleration, so it didn't spill at all. And how does it doesn't get any better than that,
Yeah, I've actually, that conveyor belt, I know exactly which one you're talking about. I've actually shown that at shows before.
Oh yeah, it's a great example.
Yeah, I had it at, what was it, Embedded Systems Conference or EE Live or whatever they were calling it this year.
That's where I met you. I met you there at the end of
that. Yeah, absolutely. Yeah, you had your Google Glass on.
That's right, yeah. So you were going to tell us about these Clark and Park. What the hell are those?
Oh, right. So that's so one of the things that happens in this algorithm, and the way that we solve the control problem, is we move our point of reference of kind of where we're observing things on the motor. So instead of being kind of external to the motor, we do our math like we were sitting on the motor and everything else was rotating around us. And I believe, if I'm not mistaken, that the Clark and Park transforms are ways to go between those two spaces, math-wise, if I remember correctly. But I could be completely wrong here. So
no, that makes sense though, because then you'd have all the transform would actually refer to like the coordinate shifts and all that crap, right? I mean, that would be
exactly.
Okay,
exactly.
I did get scared off by a bunch of the math. I do remember that.
It's pretty intense stuff. Video online by a guy called his name is Dave Wilson, and so he's one of the guys kind of behind this. I'm trying to find it now, but it's somewhere on here.
Yeah,
it's a really great video.
There's also a wiki page that helps me out. I've been reading a bunch, so I'll post that as well. That has some more info on this stuff, but.
Yeah, I'll try and find a link to the video and send it to you so we can put it on there.
Okay, cool. Well, that's good. So do you get to like go out to like test facilities and see this stuff in action then too? I mean, like
I haven't really gotten an opportunity to do that yet, but I have some counterparts that have, and we've gotten some really cool videos back of customers. We'll give them this technology, and in 30 minutes to an hour, they'll take one of our kits and hook it up to whatever physical system they have, and they'll get things tuned up, and they'll be able to run their application kind of just like that if they've got the motor control background to kind of understand this stuff, because it is it's like we were saying, it's pretty high level tough math.
Yeah. Oh, don't feel bad that I didn't do it right. I didn't have anyone here, and I kind of fell off the wagon, so.
It's all good.
No, the thing that's interesting about this, too, I think we had talked about this on a previous show, but, I didn't quite realize the scale of where this stuff's going to get put in, right? I mean, this could very realistically enable, they already have some of this stuff, but, thinking, even a refrigerator, right? A DC refrigerator. Right now, very, very difficult. But even if you wanted a higher efficiency AC fridge, you'd probably rectify AC coming in, store it in a high voltage pack or high voltage bus, and then you do the same thing because you can optimize it and control it, like you said.
Absolutely,
and that's really cool. I mean, and the same thing I was thinking about. I've always wanted to put solar panels on my house. Dave's done that, but he doesn't. I don't think he stores it. I have a friend that stores it. I think Martin's doing that. Martin Lorton here in town, and thinking about, well, that's only so much good as you have to reinvert it then, but then you have losses there. Why not just directly, if you had a water pump or a well pump, you could start to do that thing. Anything that needs to move, you can really start to move from a DC solution straight into motion with this kind of stuff.
Absolutely. And you mentioned a lot of applications there, and I think for every application you mentioned, we've got kind of a customer somewhere that's doing that.
Yeah.
With InstaSpin, yeah.
Yeah, and that's the thing. I mean, with all this crazy math, you have to kind of take it down for the dummies like me. Or not even dummies, but just people that aren't concentrating on it,
sure,
you basically offer that solution and charge some dough on top.
Yeah.
So that's cool. Yeah, I was surprised too about that. They said that so the InstaSpin stuff, you actually sell the ROM on top of the chip, right?
Yeah, so the InstaSpin devices, the special thing about them is the code in ROM. That's what differentiates them. So the thing in ROM, we call it fast, and basically what it is, it's a software encoder. So that's what we send those current and voltage signals into, and basically it spits out flux, angle, speed, and torque, and that's what we feed into our control algorithms. So that's the kind of special piece, the IP that we've added there, and that's what we charge a little bit of a premium for.
Right, and people pay that. I mean, that we've talked about, Electric Imp, right? They are basically they charge more for the fact that you're using their systems and stuff like that. It's on top of the chips, and then you just kind of don't have to worry about that stuff.
Right.
That's the idea.
Yep.
Oh my God, there's so many graphs here. I shouldn't have scrolled down. I'm having a panic attack again. So that's the other thing, though. So these all these C2000 chips also have a bunch of ADCs on board, right?
Oh yeah. So we've got, I would argue one of the nicest ADCs on a microcontroller. So they're all on most of the current devices. They're all 12-bit. I think they're almost 4 megasamples, and they've got several channels. So they're really optimized for these real-time control applications. So we've got special linkages between different peripherals in the chip that allow them to trigger an ADC conversion. So if you think, so if you think about a switching power supply application, right? You're going through cycles, adjusting duty cycles based on some reference point somewhere in the circuit. So what happens is basically we set these trigger points on the PWM. We call them compare values, and we've got a couple different channels. And each compare event, when it happens, you can have it set the PWM, set it high or low, clear it, toggle it, do a number of different things. But those events can also trigger the ADC, so that you always sample that reference point at a fixed time in your cycle. So it's very, very deterministic.
Ooh,
and
yeah,
that's good. Yeah, that's one of the things that kind of differentiates our ADC from some of the other devices that are out there.
Okay, so you just mentioned. Okay, I'm going to go back to RTOS again. So you mentioned deterministic, which I know that a lot of RTOSs care about. But again, this is not. This is just running like super loop style, just as fast as possible type of thing. Or how does that all work then normally?
Yeah, so a lot of times the control application is kind of completely interrupt driven. So you've got this kind of loop going in the background that's reading your ADC, getting that value from the system, comparing it to some reference value, and then running your control loop and updating the PWM. So the ADC would exit after that, the rest of the cycle would go through, and then it would get interrupted again. So that's typically what would happen. And then the rest of your application, maybe the user interface or communications, things like that, those would run in like a main loop, kind of outside of that interrupt context at a lower priority. Now you can also implement all this stuff in an RTOS. So, for instance, TI RTOS, if you plug interrupts into the hardware interrupt handler, there's some amount of latency added, right? When an interrupt occurs, it actually interrupts, like the scheduler for the RTOS, and it says, okay, this interrupt service routine needs to run, and then it transfers execution to that interrupt service routine. So there's a little bit of latency there. But like what I was saying with TI RTOS, we have a way that we can actually unplug certain interrupts from the RTOS interrupt handler. So we can actually keep those outside of the context of the RTOS and at the highest possible hardware priority. So we've got, that's one of the nice things about, having a team within your organization that develops your RTOS is to have that tight integration like that.
How often do you see people? So you mentioned like a display and stuff like that, and we were talking about interrupts and stuff like that. How often do you see people actually using this as like a centralized type processor? Is this kind of like, do people use this as a peripheral processor and then have some kind of like slow running Linux type of thing with a display, or running some other kind of fancy interface?
So these aren't typically used so much for like communications and user interface and things like that. These are really typically more targeted at these control applications. That's not to say they can't do it. They absolutely can. I've hooked up Launchpads to all kinds of different LCD displays. I have a board in my office that it's got like a 7.5-inch diagonal RGB LCD with a parallel interface. We can do stuff like that, but typically that's not where we play. So we're certainly capable, but that's not really what we're known for.
Right. Yeah. Well, I mean, I imagine even if you did implement something like that, it's like, oh, well, the motor kicked on, so this display will update soon. Well, it's getting there.
I mean, if you properly partition your application and design everything correctly, it doesn't have to be that way. And so, we've thought of that, and we've actually integrated little coprocessors into the chip. So we've got on some of our devices this little thing called the control law accelerator. And what it is, it's a little separate coprocessor, and it can run code just like your main CPU can. And so a couple of years ago, I think about 2 years ago, we came out with a C compiler for it. Before that, it was assembly only. And basically, we can run our little control algorithms in there. So the interrupt fires, it starts a task in the CLA. The CLA gets the ADC result, computes the control algorithm, and then updates the PWM, and the CLA goes back to sleep. So you can actually have a control application running on the CLA, and your CPU could be sitting there, in a while one loop if you wanted. But you're not going to do that. You're gonna make use of the CPU.
Okay, yeah, that's cool. That's really cool. So what was it called again? CLA?
Yeah, CLA, Control Law Accelerator.
Control Law. Sounds like a robotics type of thing.
Yeah.
Control law and stuff, and 3 laws and stuff like that. Do you guys see a lot of robotics type stuff? I mean, are you seeing anything like that?
I'm not super privy on the stuff we go into. They tell us the kind of big stories and the big wins, the companies that you and I have heard about before, but I don't know everything that goes on there.
Well, it's a big old I mean, it's been, what is it, 15 years now or something like that? Me and Dave were talking about the TMS 320 that's in there, right? That's the core DSP that's in there, and he's like, yeah, I used to program one of those.
Well, it's not actually. So it has the TMS 320 PICs on it, but that's not. It might be related to that core. I think it's loosely related, but it's changed a lot since then. Yeah. So the core that's in there now is called the C28X.
C28X.
Yep.
Oh, okay. Yeah, because some of the old, I was looking at the part numbers as well, like the C5000. Oh, I guess that's a different family, huh? C5000 has the prefix. So.
Yeah. So that's a low power DSP is the 5000.
Gotcha.
And we had devices before this. There was like a 24X, I think, before this. And then there was some devices that shared a predecessor of that that I think were used in hard drives or something like that.
Oh, cool.
Yeah.
That's really cool. Man, so no more motors or anything crazy like that, huh? You're just gonna jump straight over to Launchpad and do all the fun stuff as well.
Yeah. Well, I'm still very interested in motors. They're make the world move, really, in some ways. So one of the
how many T-shirts do you have that say that on it?
Actually, none. I just came up with that. I should trademark.
Yeah, there you go.
Or something, huh?
Start selling T-shirts in the cafeteria.
Yeah, could make a killing. No, but I've been. You may have seen it online. I like to talk about it sometimes. I've been working on this quadcopter, and so I hate drones. The word drones, I think it's not a very accurate word and doesn't really describe what these things are. But I'm designing a quadcopter using some of the InstaSpin field-oriented control technology. And so it'll be based on
I didn't realize you were using that. That's cool.
Yeah. So we've got, 3-phase brushless motors. We're doing, all the current and voltage sensing on the board. I'm really, really pleased with how the motor driver board came out. It's got some issues that I'm still debugging. One of the current feedbacks is acting a little weird on this board. So I still have to debug that. But it's really starting to come together. So I'm actually going tomorrow morning to a shop here in Houston that cuts materials for signage applications. Think displays for trade shows, road signs, things like that. They work with this material called dye bond, and so it's a aluminum laminated polyethylene kind of sheet. And so they're routing some of that out for me, and that's going to be the frame of the quadcopter. So I'm going to go pick that up tomorrow, and then I'll finally be able to kind of do a full mock-up of everything kind of assembled together. So I'm really excited to see that.
Do you have a badass name for the quadcopter yet, or no?
Not really. I've just kind of been calling it the kind of InstaSpin quadcopter, something like that. We'll see. We talked about potentially crowdfunding it or something like that, but we'll see how it goes. This is all just kind of a fun project for me right now.
Yeah, that's awesome. So what's the relative size? Is this a smaller size?
Yeah, it's a smaller size. It's designed to be low cost, so it's probably about a foot square. Looking at the BOM cost and everything for all the components, it looks like it'll come out in the $200 to $250 range. And so it's all open source, very hackable. I just wanted to kind of, launch a Launchpad, for lack of a better word.
Yeah. That's awesome. So what is the so you said the dye bond stuff? Dye bond, is that what it's called?
Yes, dye bond.
So that'll actually be this will mount on top of that. This is so people that are listening only and haven't seen the pictures, though I recommend you see it. It looks like a square, and then you kind of took out shallow half moon, so it's kind of going out towards the four corners,
right?
To connect to something.
Yeah, that's the motor driver board, and so that will basically attach to the frame. There's headers on there to plug in a Launchpad, and I've got a hole cut out in the frame for the Launchpad to kind of sit inside. And then there's another piece to the frame that sits on the bottom that all the motors attached to, and then I've got these little spars that should just snap in there. Fingers crossed.
Of course,
we'll find out tomorrow. They should just snap in there, and then the thrust of the motors should actually put the top piece of the frame in tension to help give it strength. So I put a substantial amount of thought behind kind of how to orient everything to make everything as low cost as possible, but still kind of strong and lightweight.
Wow, that's awesome, man. Yeah, and 250 is good as well. I mean, I've looked at quads a couple times there, and there's some smaller ones that are toy-like.
Right.
There are some Kickstarter ones that are a little bit cheaper, but yeah, nothing really. It needs to keep getting pushed down by stuff like this, so that's really good.
Yeah, it's kind of in between the little low-end toy ones and like the mid-range, kind of halfway professional ones. So I'm excited to get it up in the air and see where it takes me.
So do you? There's no RF. Do you have an external receiver for the RF stuff, like for the control?
Yeah, I had originally intended to use some more TI components there, but I just kind of, this project has dragged on for a while, and so
Gotcha.
I took the easy route out there. So I'm using kind of an off-the-shelf transmitter and receiver. But from Hobby King, I mean, they're so low cost. It's like,
oh, I know, yeah.
Yeah, I just wanted to save myself the hassle.
So I see on the I'm looking at the 43o.com. I'm not sure what that site is.
It's an MSP 430 kind of enthusiast site. That's why it's 430.
Oh, 430. I get it. Okay.
Oh, yeah.
Yeah. So, but this is using the Energia, right? So, Energia. You didn't tell me that story. You have to tell me that story.
Yeah, Energia. So
Gia.
Yeah, the story behind the name. Okay, so right, it's Launchpad, right? We've got a symbol that's a rocket. That's our logo. And so Energia, if you're familiar a little bit with the Soviet space program, they actually made kind of a knockoff space shuttle called I think the Brand spacecraft or something like that. Well, Energia was the big rocket that carried that spaceship into space. So that's why we call it Energia, because of the rocket ship.
Right, okay. Okay, I like that.
Yeah.
Okay, that makes it a little better.
It's kind of a little cohesive, at least.
I'm just saying, why isn't it a soft J? Can I just say the soft J? Like the hard G, it doesn't do it for me,
Yeah. What would you like it to be?
Energia. Energy. Like, it looks like energy, right? But
I used to say it that way, but then this project's lead was like, "Oh, it's pronounced Energia," and so I was like, "All right, you're the boss."
Yes, we all make sacrifices for workplace harmony. So I guess I'll be okay with that.
Now,
so did you actually fly one of these at Maker Faire? Because you were at Maker Faire as well.
Yeah, I was at Maker Faire. Sadly, things didn't come together in time. I had actually asked a special favor to kind of get some of the parts cut. I knew some people that had a water jet that wasn't used full time. And so, I sent some material to them to see if they could cut it for me. And they tried to, but they ended up just not having time to. So it didn't come together in time for the Bay Area Maker Faire. But it's close. We're getting dangerously close. We're in the finishing stretch here.
So we might see you at the. Are they doing another quadcopter? If people don't know, there was like a huge stadium for quadcopters, and like some of them were like actually battling. And
yeah,
crazy
Game
stuff
of
like
Thrones. That was pretty sick.
That was. I don't know why anyone would do that.
Yeah, throwing your $500+ quadcopter into a netted off arena only to try to destroy another quadcopter. As cool as that sounds, I don't know if I want to be the one flying my quadcopter in there, trying to break it.
Right. Yeah. I mean, if you want to have a contest for like, I get through these different markers and all that stuff, that's fine. But yeah, sure. I don't know. I don't.
Yeah. I think I'd rather participate in SparkFun's, ABC or something like that.
There you go. Yeah. Yeah. You haven't done that yet?
No, I haven't done that yet. But, once I get this thing flying, it'll be a great platform for things like that. I don't think it would make a great fighting platform. I think it could fight, but
Well, yeah, and if it's cheaper, right? I mean, that's cool.
That's true. But there needs to be kind of different classes, for those things. I think they all just kind of lumped them together. Just like fighters have weight classes. I think they should have done different classes for different configurations and quadcopters and weights and things like that.
Right, just like BattleBots too.
Yeah, exactly.
Sadly was canceled.
I know, that was like the greatest thing ever. I loved that as a kid.
I knew one of the guys that entered the wedge. The wedge always wins.
Oh, yeah.
That was his motto.
I always liked the one that they like spun around, the top spun around, and they'd have like big weights, and it was just like all like thick sheet steel, and like nothing could penetrate those, as long as you didn't flip it, you know?
Right, of course, right.
Yeah.
They're like horse-shell crabs, right?
Yeah, exactly.
Yeah. Well, that's great, man. So you're going to be starting as the Launchpad. You're like the honcho now, huh? Like you're the...
On the technical side of things. So I've got a counterpart, Adrian Fernandez, and so he's kind of the marketing side, and I will be more of the technical side. But I'll still get to do a little bit of marketing work. So I like going out to shows and talking to people, and doing stuff like this to kind of spread the word about Launchpad. So I'll be doing that, but then also kind of making sure that we're all aligned within TI, so that as we move forward, the Launchpads, work together very well. Software is portable, booster packs are portable. Just having a consistent experience for the user across Launchpad. Exactly.
Yeah, that's good. So people are going to be able to see you at shows coming up. Is that a likely thing?
Yeah, I should be at the New York Maker Faire. I still need to travel for that. But excited to go there. I've never been to New York, so the most I've been through that area is I had a flight that I connected with it in Newark, and as we were landing in Newark, I saw the Statue of Liberty out the window. I was like, that's pretty cool. But really excited to go. And then before we started recording the show, Dave and Chris were trying to kind of get me to go to the Open Hardware Summit and Maker Faire Rome. So I know people actually that are going to that. One of my good friends that works at Digilent, Larissa Swanland, I think she's going to that. So I'm going to try and use the justification that Chris and Dave provided me with, and we'll see if I can convince management to let me go.
you got to go, man. Yeah.
I've got a passport, so I'm ready in that regard.
Right. All you need now is just add money. Just add money.
It's always the easy part too, right?
Yeah, of course. Well, that's great, man. So where can people find you and beg for Launchpads on Twitter?
So on Twitter, I'm at YERTNAMREG. So that's Yert Namreg. And as Chris was saying earlier, that's my name backwards. So you can find me there. I'm active on c2kcentral.com, so it's kind of a third-party community website for C2000 things.
Oh,
cool. There's also 430, so sometimes I check in on there, so 430.com. And then I'm also on the TI E2E forum, so if you didn't know about this, when you've got a problem with a TI part, we've got online forums on our website where you can go and ask questions, and it's people just like me that actually work with these products, design these products, that answer these questions. So if ever you think you found a bug with a hardware or something like that, you can get on there and get a real expert to look into it. So you can also find me there.
I was really surprised. Yeah, I've had friends who are applications engineers at TI, and they're like, yeah, I spend like 10 to 20 hours a week on the forums. That's like crazy. I'm not saying it's everyone, but like that's a crazy amount of forum work. But I mean, that's just a big part of communicating these days.
Absolutely, and that's that's the dedication we have to our customers. I remember what it was like, kind of being on the other side, outside, trying to develop applications, and oftentimes it can be frustrating. You're like, why isn't this darn thing working? And we're there, and we want to help you. So.
Well, cool. Good luck with the new role. We'll see you at lots of shows, I'm sure. And thanks for coming on the Amp Hour.
All right. Thanks a lot. I've got a jet engine in my spare bedroom. Let's see. I'm a pilot. Just started powered paragliding lessons. I
saw that picture on Twitter. Yeah, for sure. That's That's pretty cool.
We didn't get into the racing lawnmower in college, or the Tesla
Oh,
coils.
jeez. How did we skip all that stuff, man? That's crazy.